Most digital security relies on a single layer of obfuscation, a scrambled string of characters that stands between an outsider and your private data. We are going to bypass that barrier by building a functional, interactive Python password cracker from the ground up. Our method is the dictionary attack. While a brute force approach tries every possible character combination, a dictionary attack targets the human tendency to use recognizable words, making it significantly faster and more efficient. The script will take a list of plain text words, run each one through a cryptographic function, and compare the resulting hash against our target string to see if the two values are identical. Constructing this offensive tool demonstrates the technical reality of why simple passwords are easily compromised, and why high entropy complexity is a baseline defense. To start, open your editor and ensure you have a text file containing common passwords saved in your local project directory. We begin by importing hashlib. This is Python's standard library for secure hashes and message digests, providing the mathematical functions needed for the comparison. The script then asks the user for two pieces of information: the target hash we want to crack, and the name of the word list file we're going to use as our dictionary. Since users can mistype file names, we wrap the file opening logic in a try-except block. This allows the script to report a missing file, rather than crashing the entire process. Handling these potential errors ensures the tool remains operational and provides useful feedback even when the input is incorrect. Next, we create a for loop. This will iterate through the word list line by line, testing every entry in the file until it reaches the end. Cryptographic algorithms require specific byte formats. We use .encode to convert plain text words into UTF-8. We also strip away new line characters or trailing whitespace. The cleaned word is hashed using MD5, producing a unique hexadecimal string for comparison. Digital signatures leave no room for deviation. If a single space remains attached, the resulting hash will change entirely, and the match will fail. Now we implement the logic. We check if our generated hash is exactly equal to the target hash provided by the user. If the hashes match, the script prints the discovered plain text password and uses the break command to stop the search immediately. To track progress, we use a Boolean flag. Setting this variable to 1 inside the success block creates a permanent record of the match. Once the loop concludes, the script checks the status of that flag to determine its final output message. If the flag remains at 0, the script notifies the user that the target password was not found within the provided dictionary. Failing a dictionary attack proves the password isn't among the common words in that specific list, meaning an attacker would need to pivot to larger datasets or more intensive cracking methods. Now that the core logic is fully complete, we can execute the script in a live command terminal environment. We run the Python file, paste our target hash, and point the script toward our dictionary of common passwords. The script iterates through the list in milliseconds, identifies the matching hash, and reveals the original plaintext password. This demonstration highlights the vulnerability of standard dictionary words. If a password appears in a common word list, it can be recovered almost instantly. Building these tools provides the hands-on experience necessary to understand and implement stronger security. Subscribe for more deep dives into cybersecurity engineering.